What's up, everybody? Welcome to Earth Science. So, if you're looking at this and panicking because it looks like you got to plot a ton of numbers, don't panic. You have to plot a grand total of 6 numbers, nice and easy, so we can make this lab go quick. You're going to plot the average and the class average. So, my recommendation is to pick a color and say these are going to be orange, and these are going to be purple. I don't care whatever colors you want to use. Make sure the dots are visible, though. What you're going to do then, now obviously I don't have numbers in here yet, right? You're going to take your 3 averages for your small, which were 4 millimeters in size, mediums, and larges, which were 8 and 12, and go to whatever number you get here. Let's say the 4 took exactly 4 seconds, which it didn't. You're going to probably have something different. I'd put it right there. Let's say the 8 took 3 seconds. No, actually, I want to do it a little different. Let's say the 8 took that long, and let's say the 12 took, I don't know, that long. Now, that's it. Throw those 3 points and you're good. When it comes to the line, though, this is going to be where I want you to do something slightly different than we've done in our science. Grab the same color, and I want the line skinnier than the dots. What I want to do is a best fit line, which I'm sure you've heard of in your math classes. One straight line that best represents those 3 dots. So, that's not going to be the tool, is it? So the advantage of Cami here is going to be that, like, you can chuck it and then play with it. So let's say you do that, and I don't like it. Can you edit these? If not, we could. Yeah. So if you do your pointer exactly, this will be great. So you can monkey with it until you get it right about where you want it. The idea would be what one line is best at representing those 3 dots. What would be so that the difference in distance is about the same on average across the board. I'm thinking something like this. Looks good. Okay, that's it. 3 dots, straight best fit line all the way across the graph. Then do it in your other color for the 3 class average numbers. Dot, 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 and a best fit line. Yes, they may be pretty close, but yes, you folks are smart enough to figure that out. Okay, that's going to be very helpful when it comes time for these 2 questions here. How quickly would a particle of 10 millimeters settle? How would you know? How quickly would a particle of 15 millimeters settle? We didn't have beads that were those sizes. But if we figured out the relationship mathematically, between the size and the settling time, we can do it, right? You didn't have a 10, but you've got a graph that has a 10, and you got a line that says how long it took. So you can figure it out. The 10 millimeter would take this long. Go to the 10, up and over. The 15 would take this long. Go to the 15, up and over. And tell me, according to your graphs, how long those take. All right, what else? These 2 questions are different. They're not the same answer. Hint, hint. Rate is a speed. How fast is it going? Time is time. How long does it take? If somebody goes fast, they take less time. If a bead goes fast, it takes less time. If a bead goes slow, it takes more time. So these 2 answers are going to be different. Just pause for a minute. You can do it. Remember, when somebody says state the relationship, the first word you use is as. And then tell me, as particle size does something, what happens to the settling rate? As particle size does something, what happens to the settling time? You can do it. Think about those 2. You can do it. Think about this one. The beads in this one work pretty solidly, but some of you saw some funky things that happened that maybe would make one of those outlier numbers happen. All right, rate of change time. This lab's going to be incomplete unless these are done properly. All right, it is time that we are all grinding these things out the same way every time and just crushing it. Change in value over time. The change in value in this lab would be how far was it from one line to the next, which was 50 centimeters. That will be over, maybe with a smaller pen, but you get the idea. That'll be over how much time it took. Let's say it took 4 seconds, which again, use your numbers, not mine, and learn to spell. Sorry. Okay, equals. Then grab a calculator, type 50 divided by 4, or whatever your number is, 12.5. And again, your number will be different. Now, your label is exactly what it says here. You could do it either way. You could say in this box, centimeters per second, break it right at centimeters over seconds either way. But all of this is part of how you do one of these things. So 50 over the time, 50 over the time, 50 over the time, all 6 times. And then think about what particles settle fastest. If you can do that, you can do this Regents question. All right. Good luck, everybody. You can do this. Pump it out, get it done so that this thing doesn't linger. So long.